Hello, Mr. Fries, Algebra 1B. This is April 22nd, and I'm looking at Unit 8, Homework 2, Graphing Quadratic Equations. I'm going to do the first couple with you. I'm going to do the odd ones, and I'm going to give you some guidance on the even ones, but here we go. So what we're going to do is you're going to want to plug this into either your graphing calculator, and you can get the tables on your graphing calculator, or Desmos. As my graphing calculator, the batteries went dead. So on Desmos, you can plug this information in Desmos also. Sorry about that. I was looking at Desmos there for a second. Okay, so when you are plugging this in and getting the information, when you go to your graph on your calculator, when you hit the second button and hit graph button, which is table, which would be right here, or if you're at home, when you plug this in, I might as well just show you it plugged into Desmos. So we don't need to put the y equals, we could just put x squared. You could put the y equals, it's not going to change anything. Plus 10x, and then plus the 26. So I get this out of the way. Okay. And then I gotta look for it over here. Okay, right here, if I click on the problem again, right here is my vertex, -5, 1. So that's my vertex. The axis of symmetry is -5. So x equals -5. So notice that this x value is -5 all the way up and down. That's the axis of symmetry. That goes right up the middle of this U-shaped or this smiling positive quadratic equation. Notice it's positive because this x right here is a positive x. If it was negative, it would be upside down. All I need to do is change it to a negative, and just to show you, it will switch to, way up here. Go like this. It switches to a negative. Okay, so it goes upside down. So get rid of that and get back into it right here. Okay, so just to show you, that's why it's positive. Or that's why it looks the way it is, because it's positive. So your all real numbers for the domain. Domain, remember, is all the x values that you could plug in. Whenever you plug in an x value, are you going to get a point on here? So yes, because as this goes up this way and as it goes up this way, it's going to continue to go on infinitely in both directions and cover all x values. So all of these, we're going to have a domain of all real numbers. The y, the range, all the ranges have to be above this point. So, which is where y equals 1, right? Where y equals 1. Okay? So, everything above y equals 1, so it's y is greater than or equal to 1. Okay? Now, on Desmos, you could just, you'll have to figure these out, but on your graphing calculator, it will give you that, the amounts that you need. You'll find where it changes direction and then goes back up in y values, so it comes down and then goes back up, or it goes up in this instance because we have a negative. It goes up and then goes back down. That's the point of the vertex. It's going to be right in the middle. And then you take two numbers before and two numbers after on your x values, and then you just figure out what the y values are. So -6 and -7. So you would look here at -6, and when I'm at -6, it's hard to get it just perfect. I'm at 2. And notice my 4 is also at 2. It's hard to get it right on. So -4 and 2. Then you would do the same. You just follow the line up to the previous number, -7, and you'd notice that the y value is 5. And you could just look at it. You don't have to put the dot on it, but you could see 7 and 5. 7 is 5 here. That's my 7. And then negative 2, or I'm sorry, negative 3. And then my negative 3 is also at 5. So negative 3, 5. So that's how you would fill out this T-chart. I'm not going to show you that every time because this would be an hour-long video. You just plot these points, and you could see, you know, the axis of symmetry would be right here. That's where the x value is negative 5, like we said earlier. And you can see the vertex where it changes direction, negative 5 and 1. Okay, plug this one in, and you'll get, you'll be able to see where x equals 2. It'll actually look like this. The x value is going to be 2, so that's going to be the axis of symmetry. And so at that point, it's 2, 8. So you put that in your center right here, 2 and 8. And then you go ahead and get 2 numbers before and 2 numbers after. And you can just plug that into a regular calculator. You could just plug in, okay, so what would 1 be when x equals 1? So negative 2 times 1, and then square it, plus 8 times 1. Notice I put in parentheses where my x value is, because I could equals, and I get 6, right? So I put in a 6. Because I can go back, I could just use the back button under just a regular calculator and change it to 0, and change my x value to 0, wherever you see x value, and then plug it in, and I get 0. So when x is 0, y is 0. And then say I wanted to check out, well, what about the 3 and the 4? Well, I could use the back button, go into parentheses, plug in the 3 when x equals 3. Don't forget the other x value. And you get 6, and so on. And 4 is going to be 0. You're going to notice a pattern. You know, it goes up, and then it repeats down. Okay? Or it goes down and then goes back up, and it repeats. Okay? So this should be your number 2, and then you just plot those points. Number 3, I want to do all the odd ones for you. So once again, you could plug this into your calculator, and you can, you know, get the graph, find the vertex, and then get the 2 numbers before and 2 numbers after. Do it that way, or you could plug it into Desmos as I've been showing you, and then just go ahead and graph it. I did not graph this one, so let me go ahead and graph this one. It's negative 1, 3, 1, 2, 3, 0, 0, which is going to be right there. 1, negative 1, 2, 0, and 3 is going to be 3. So it's going to look like that. Not perfect, but good enough. Okay, you can see the axis of symmetry is going to be 1. It equals positive 1. I'm going to, the vertex is 1, negative 1. And the range is going to be, y is going to be greater than or equal to negative 1. Okay. I'm going to tell you that these are the numbers, and you can go from there to fill out this information. Just follow the pattern that we've been doing, and then you could plot these points over here. So there's your numbers for number 4 to help you out. For number 5, when you plug this into Desmos, or you could figure out, you know, you could figure out the vertex form. There's that formula that you can use also. You can figure out, you know, 0 and negative 5, and then just grab 2 numbers before and 2 numbers after your vertex. Plug these numbers in, negative 2 in for x, and you'll get 7. Negative 1 when you plug it in for x and work it out just on a general calculator, you'll get negative 2 and so on. Okay. Then you'll graph that over here. I have a picture of my graph, which is not an art project, but they don't have to be. For number 6, I'm going to give you a little bit of help. I'm going to give you all the x values. And this happens to be the vertex. 3, 3 is the vertex. So you'll go from there. Plug in 2 to x and work the problem out and see what you get for y. Plug in 1 for x and see what you get for y. And then this should be the same as your 2, and this should be the same as your 1, the y value. And number 7, using the vertex formula, you could figure out the vertex and then go from there, or you could plug it into Desmos as I did, and you can then find these on the graph. And then here is the graph of that, all those numbers there. Hopefully you pause that on there and get that information. And then number 8, I'm going to let you know that you should be using 2, 3, 4, 5, 6. 4 is going to be 1/2 of the vertex. You can figure out the other half by just plugging in 4 to your x values, and then graphing it. Okay, good luck on the ones that you're on your own, and have a good Thursday.